Now that we learned some of the fundamental trigonometric identity, let's see what can we do with them. Similar with algebra, first thing we want to do is we try to see if we can simplify an expression. Okay, so write one trigonometric function in terms of a single trigonometric function or a constant. So we want to simplify the expression. So first, we're given tangent of theta times cosine of theta. So here's a little tip for you. If you are given tangent of theta and you don't know what to do with it, or they're not an identity immediately jump out at you, the first thing I would want to do is to rewrite it in terms of sine and cosine, and maybe some Pythagorean identity will jump out, or maybe we can just simplify it as it is. So let's take a look at this one. Well, I can rewrite tangent of theta as sine of theta divided by cosine of theta times cosine of theta. I can simplify cosine of theta and we are left with sine of theta. Well, in the next one, there's really nothing immediately jump out at me. However, if you look at the numerator, we have 1 minus cosine squared of theta. So recall we have something, the Pythagorean theorem, that involves a square and 1. So sine squared of theta plus cosine squared of theta equal 1. So sine squared of theta is actually 1 minus cosine squared of theta. This means I can rewrite the numerator as sine squared of theta divided by cosine squared of theta. Well, this is tangent squared of theta. Cosine of theta times cosecant of theta. Well, cosine of theta, there's nothing I can do. But cosecant of theta, that is 1 over sine of theta. So we have cosine of theta divided by sine of theta. This is cotangent of theta. Next one. Well, I don't know what to do with this right now. There's not really an identity that jump out. So let's go ahead and rewrite everything in terms of sine and cosine. So sine of theta times 1 over cosine of theta divided by sine of theta divided by cosine of theta. Well, the numerator becomes sine of theta divided by cosine of theta. The denominator is sine of theta divided by cosine of theta. So this is 1. So let's say we are given the value of an angle or some information. We want to use this information to find the value of the missing trigonometric function using known identity. Okay, so first of all, in order to appropriately determine whether the trigonometric identity, whether the trigonometric function are positive or negative, we want to see what quadrant is it in first. So here in part A, you are given that sine of theta and cosine of theta. So sine of theta is positive and cosine of theta is negative. This meant that theta is in quadrant 2. So this is positive, this is negative. This implies that theta is in quadrant 2. Okay. So in quadrant 2, sine of theta is positive, cosine is negative. Now, we want to use this to find the other 6 trigonometric function. Well, the first one we find is tangent of theta, since we are given sine and cosine. So root 2 over 2 divide negative root 2 over 2. This is negative 1. So then cotangent of theta is just the reciprocal of tangent of theta. So that is also negative 1. Cosecant of theta is 1 over sine of theta. So that is 1 divided by root 2 over 2. So that is 2 over root 2. That equals root 2. And secant of theta is also equal to negative root 2. Now cosine of theta equals negative 3 over 5 and sine of theta is greater than 0. Well, this means that theta is in quadrant 2, right? The same. So I given cosine of theta, we have a trigonometric function that involves sine of theta and cosine of theta, that is the Pythagorean theorem. So sine squared of theta plus cosine squared of theta equal 1. So sine squared of theta equal 1 minus cosine squared of theta. That's 1 minus negative 3 over 5 squared. That is 1 minus 9 over 25. That is 16 over 25. If sine is greater than 0, which means sine of theta equal to square root of 16 over 25, and we only take the positive part. So this is 4 over 5. Tangent of theta is equal to 4 over 5 divided by negative 3 over 5. That makes negative 4 over 5. Cosecant of theta equal 5 over 4. Secant of theta equal negative 5 over 3. And cotangent of theta is equal to negative 5 over 4. For the next one, for tangent of theta equal x over 5, for theta is in quadrant 3. So we are given theta in quadrant 3, which means sine of theta and cosine of theta are both negative. We have one trigonometric identity that involves tangent. That is 1 plus tangent square equal secant square of theta. Okay, this means secant square of theta is equal to 1 plus x over 5 square. And that is 5 plus x square divided by 25. Well, secant of theta is equal 1 divided by cosine, 1 divided by sine of theta, which then telling us that sine of theta, let's finish this first. So secant squared of theta equal to negative square root of 5 plus x squared over 25. Because sine and cosine is negative in this case. This means that tangent and cotangent is positive, everything else is negative. So we get negative root 5 plus x squared over 5. Then this means cosine of theta equal 5 divided by negative root 5 plus x squared. Rationalize the denominator. We get negative 5 times root 5 plus x squared divided by 5 plus x squared. Now we have cosine of theta. We can find sine of theta. So sine squared of theta equal to 1 minus cosine squared of theta. So that is 1 minus 5 divided by negative root 5 plus x squared. That is 1 minus 25 over 5 plus x squared. We can either simplify this, or we can just say, well, then sine of theta equal to the negative root of this 1 minus 25 over 5 plus x squared. Cosecant of theta is the reciprocal of sine of theta. So that is just 1 over square root of 1 minus 25 over 5 plus x squared. And lastly, cotangent of theta, that is just 1 over tangent of theta equal 5 over x. Now, if we're given secant of theta equals 17 over 5 for theta in quadrant 1, again, I can use the Pythagorean identity. 1 plus tangent squared of theta equals secant squared of theta, which means tangent squared of theta equals secant squared of theta minus 1 equal to 17 over 5 squared minus 1. 17 over 5 squared, that is 289 over 25 minus 1 equal 264 over 25. We will simplify this. Since tangent is in quadrant 1, we only going to worry about the positive part. So tangent of theta equal root of 264 over 25, and that is 2 root 66 over 5. Then we have cotangent of theta equal to 5 divided by 2 root 66 . Secant of theta equal to 17 over 5. This means cosine of theta equal 5 over 17. So then sine squared of theta equal 1 minus cosine squared of theta equal 1 minus 5 over 17 squared. That 1 minus 25 over 289, and that is 264 over 289. And so sine of theta equal 264 over 289 square root. That is 2 root 66 over 17.